Hello. This one's going to be a bit of a weird one in that it's going to mostly kind of consist of me just talking at you. Hold on, let me close the door so we don't get interrupted. And really this would be much easier to do in person, but you know, we've got to do what we have to do. So this one's about colour, i.e. like coloured light and things like that. So the first thing I want to talk about is, and it's one of your core questions, is what does white light consist of? So actually I was meant to get a torch before, just give me one moment. That's not me slamming the door, that's the wind. But I actually can't find a torch, so hopefully you have one that you could have a look at. Now, when you're in school, imagine you're in the science lab and we have those lights on the ceiling. They give off what we call white light. And surprisingly, it's actually made up of all the colours of light in the spectrum, in the visible spectrum. So if you look up the visible spectrum on Google, you'll see all the images. Then when you mix all of those colours together in terms of light, not in terms of like arts and coloured pencils and things, then you actually get the colour white, just like this paper here. Okay? I'm trying to resist the urge to talk about why things look white. So why does this paper look white and why do the walls look white, etc., etc. I need to resist that because that is for the third lesson. Is it the third lesson? Yeah, that is for the third lesson on colour, not this one because this is the first one. So white light is made up of all the colours of the spectrum. Now, what are the colours of the spectrum? Hopefully you've heard is it mnemonic? I don't know if that's the right word. For the rainbow, Richard of York gave battle in vain. Now, the first letters of those words are represent the colours in the visible light spectrum. For some reason, I always remember it as Roy G. Biv. I'm not sure. Can you actually see that? Yeah. I'm not sure where I've got that from, whether it was a Roy G. Biv. I'm not sure if I got that at school from a teacher or it could be from my granddad because he's always talking about science. So, Richard of York gave battle in vain. So if you can remember that, then you can remember the colours in the visible light part of the electromagnetic spectrum. And let me just, I shouldn't really have done arrows, I could have done this a better way, but oh well. So this is red, orange, yellow, green, blue, indigo. Oh no, what am I doing? And violet. Okay, so those are the colours in the electromagnetic spectrum. So you can either remember Roy G. Biv or Richard of York gave battle in vain, or you can come up with your own. That's always quite fun to do. So that's another question that you could be asked in your core questions. Okay. The next one is, what effect does a triangular prism have on white light? Now, luckily we've covered refraction because I'm sure you all know what's a a triangular prism, let's say. I really wish I had one here, but it's just not the kind of thing that you normally have lying around your house. Maybe as a physics teacher, you would think that's the kind of thing I have here, but no. So it obviously, if you don't remember, I should do this with a ruler, but I'm not going to. It looks kind of like that. Okay, 3D. And if you shine white light, a ray of white light at that triangular base prism, again, you've probably seen the picture of this before. I can't remember what band it is. Is it Pink Floyd? I don't know. A band, maybe it's Pink Floyd, one of their album covers or something like that. That has this on, so you've got the white light coming in. Again, it should be done with a ruler, not the way I am. Can I find a ruler so I can stop being naughty? Give me a second. Today is just not really my day for finding things, so no, I cannot find a ruler. But please don't do what I'm doing here, but remember, do it with a straight line. So this is my incoming light. Obviously it looks blue because I'm using a blue pen, but it's actually white light. And as I was saying, you probably can already predict what's going to happen when it comes back out. It's split up into its varying colours, i.e. Roy G. Biv here. Now, obviously these should be straight as well. And remembering why is it not continuing to go through like that? Because refraction takes place. So, i.e. the bending of light, so that's why it's all bending off at a different direction. And the thing to note is that, so all of these colours in the spectrum have slightly different properties to each other. Something called the wavelength of them, or you can also talk about the frequency of those colours, and they're all different, and that determines what colour the light is, okay? So when you put your white light through, what happens is your prism refracts each of the different colours of light by different amounts, and that's why it doesn't come back out as white light. It's actually separated into its different colours. In your assignment, I'll undoubtedly put a picture of a prism with actual colours rather than my rubbish version. So that's what happens. So a triangular based prism will split white light up into its different colours. Right, what are the three primary colours of light? Now, this is not the same as in art. I confess I can't remember what the three primary colours in art are because it's been so long. But when we're actually talking about light, so physics, the three primary colours are actually red, green, and blue. So these are the primary colours of light. That's supposed to be an H. Primary colours of light are red, green, and blue. And if you remember that what secondary colours are, they are the colours that you get as a result of mixing two of these colours. And you need to remember that as well. So if you mix red and green, no, hold on. I'm not allowed to talk to you about this because that is actually for the next lesson. That was close. So I'm allowed to tell you what they are for this lesson, but we'll talk about which ones mix to make which secondary colour in the next lesson. So that was close. The secondary colours are yellow, magenta and cyan. Okay, I know you're all aware of what colour red, green, blue and yellow are, unless there's some kind of colour blindness going on, in which case I'm very sorry. Not trying to be insensitive. Magenta and cyan, I find that you guys sometimes don't know what colours they are. Can I find anything around? The answer is probably no. That is magenta and cyan, so I can show you. I've kind of got a sort of cyan-y colour, I suppose. This is kind of like a cyan, this bit. You can probably already guess which two of the primary colours you mix to make that colour. That's your cyan and your magenta. Oh, I've actually found something that's magenta. So this colour here is kind of like magenta, so it's kind of like a pinky purpley, and again you can probably work out which two primary colours you would mix to get magenta. So yes, so those are the colours. Now I'm trying to decide whether to talk about it here. No, I think I'll leave it there. I know it's I think it's a short one, and a little bit boring because you're just listening to me talking, but it's what we have to do. Have a good day.